Now, before we begin with actual learning about the event queue, I want to ask you a question that I was asked quite a few times on job interviews, and one of those job interviews was for GitHub. So, what do you think? Is JavaScript a synchronous language? Think about it, and I hope you will get to an answer by the end of this video. Greetings, dear friends, fellow programmers, and those aspiring to be. Today, we will be tackling another core concepts of JavaScript. I'm talking about event queue. Understanding event queue is going to allow you to know how JavaScript tackles asynchronous code. And of course, that way allow you to utilize this functionality and write code much better that is going to be way more performant, and you will be able to call yourself a true asynchronous developer in JavaScript. And one more benefit of mastering event queue is going to be the fact that it, besides call stack, represents one of the two base pillars that have event loop on top of them. So in order to master event loop, you need to be very comfortable with both call stack and event queues. So we already covered call stack in the previous video, so if you did not see it, I think it's a great time to do just that, because you will be able to get a lot more out of this video. If you do see the previous one, you will be completely ready to learn and master the concept of event loop in JavaScript in the next video. And as usual, I'll do my best to make this as pleasant experience as possible. And now we can begin with actual topic. So first, JavaScript is a single-threaded programming language, which means it can execute only a single thing at a time. But thanks to event queue, it is able to handle multiple things at the same time virtually. So it can listen for user input, it can handle network requests, it can also listen for any kinds of events in code, all because of this concept and mechanism called event queue. The event queue can be compared to a waiting room where each task is a customer. And basically, event queue is making sure that all the customers are going one at a time in the exact order they came in. By doing this and having these mechanisms at its disposal, JavaScript is managing to behave like a multi-threaded language, even though it is not in reality. So, the event queue is holding tasks that are waiting to be executed. And when the call stack is empty and it has nothing that gets executed at the current moment, event loop takes the next item that needs to be executed from the event queue and puts it on top of call stack, and then it gets going with the execution. And by doing this, we ensure that the main thread is not blocked and is also handling multiple things at the same time. So let me show you this in action. And welcome to IDE environment. It is time to discuss how event queue works in action. So we're going to take a look at our code here, and you can see it's very simple. So we have only console log, another console log, and also we have setTimer function, which is JavaScript's included built-in function, which, as its name suggests, just creates a timeout before it executes the code that is inside of it. And basically, in this example, this right here is a timeout in milliseconds that we want to wait before the callback gets executed. So, as you can see, the timeout is 0. So, when I run this code, what do you think is going to be printed, and in which order? Did you see this coming? We have start, then end, which is here, and then in the end we have timeout callback. So why is this happening? Because we put 0 timeout here. We did not put any delay, and we still get it printed after the end statement. So why is this happening? Well, it is happening because of event queues. And just to be clear here, when I was learning JavaScript initially, I did not understand this part as well. I was so confused by this fact that I cannot even explain it. So that is exactly why I decided to make a video series dedicated to explaining this concept, so you guys would not have to struggle as I did. Okay, so what is happening in our example? So setTimeout function is creating a callback that is being pushed to event queue. And when that is done, the call stack keeps executing things that we have in our code. So it will first execute the console log that is going to print start. Then the event queue receives the callback containing the logic that is supposed to execute after setTimeout counts down, which is 0 milliseconds. But even though it's 0, it's not on call stack. So the callback that is supposed to be executed is not pushed to call stack yet. It lives inside of event queue right now. And after that is done, we push the final console log to call stack, and that is why we print end. Now, when all of those things are done, event loop notices that call stack is empty, so it starts looking at event queue and sees what it is supposed to push to call stack next. And in our case, because the timer has no counters that need to be executed, it is just supposed to execute immediately. And because the timer has nothing to count towards, because the timer is set to 0, the event loop pulls out the callback and pushes it to call stack. And now when that happens, we are actually going to get our message printed. And that is why the order of execution is start and then the callback function. Still not sure about this? No problem, do not worry. We are jumping to the drawing table, and there I will draw call stack and event queues, and I will explain exactly one line at a time what is happening and what is stored where. That way you will be sure what is going on under the hood. And welcome to our drawing board environment. I have prepared for you a call stack, also event queue and event loop. So now let us discuss what is going to happen when we execute our first example. So as you can see right here, the first line that we have in our code is going to be console log for starting our execution. And as you can guess probably, the first line is going to be pushed onto our call stack. So it drops from above and it drops down. So this right here is start. And because it's a very simple action, it gets executed right away, which means that it can again be popped off of our stack. So it will be done. Then next line that we have in our code, just a reminder, this right here is our code, we have the execution of setTimeout action. And as you can see, we have 0 timeout. So when our code gets to the line where we are trying to execute setTimeout action, it is going to take a look at the callback that is stored inside of our setTimeout function, and it is going to push it onto event queue, because we executed setTimeout action, and if we had some timeout, it would be created as a process that would be counting behind the scenes, waiting for it to count down to the end and then push the callback onto the event queue. But because we have no timeout, it is going to be pushed right away. So let us do that. So this right here is our call stack. It is going to sit on our event queue until its turn arrives to be executed. And the final line we have to execute is going to be console log, which is going to log end string. So we're going to push it again onto our call stack, and we have our end action. And again, same scenario as for start. It's a fairly simple task to be performed. It gets executed right away, and immediately it gets popped off from our call stack. So it gets out, and then our big brother or event loop takes a look at the call stack and sees that on the call stack we have nothing at the moment. So when that happens, it is going to first check our Microtask queue, and if it is empty, then it is going to check the event queue. And because we are not working with Microtask queue right now, but we will cover it, do not worry, our event loop is going to take a look at our event queue, see that we do have something that is waiting around to be executed, and it is going to take that task and push it onto call stack. So our event loop has successfully noticed that call stack is empty, so it pushed from our event queue the task that was waiting for execution. It pushed it all the way to our call stack, and now it's stored there, so it's waiting to be executed. And basically, that is going to mean that our console log action is going to be executed, and after that, we're going to, again, pull this out from our call stack, leaving our call stack completely empty, and also our event queue, again, completely empty, which means that our application has done its job completely. Right now, I expect you to be completely comfortable with event queue and you understand how it works. And because of that, I want to jump to a quick example I have prepared for you. As you can see here, we have the following scenario. We're again printing console log start, we also have console log end, and we have 3 different timeouts. And each of those has its own callback. Each one has different timeout time, and now I want you to think about what is going to be printed when I run this code. If you expected to see this, you were completely right. Because as in the previous example, we have the same situation. We're immediately printing start and end because all of our timeouts are being pushed to event queue, and then they wait for event loop to pull them out of there and push them to call stack. And because of the fact that timeout 2 has the least amount of time it has to wait, it gets printed first. Then we follow it up by timer 1, which has second largest time to wait, and finally we print out timeout 3. So I hope you managed to figure this out on your own, but if you did not, we're just getting started. You still have all the time of this world to understand this concept. Right now, I know you're comfortable with the fact that event queue handles tasks in JavaScript. But there is another queue that is being used and is working for JavaScript as well. And the queue I'm talking about is called Microtask queue. So this queue is being used for high priority tasks. Those high priority tasks are basically promises in JavaScript. So let me show you an example, and you will see that it's a very similar concept to the one with event queue. Now, we have the final example for the day, and inside of it we again have start and end, and also we have 2 blocks. The first one is going to be setTimeout with 0 time that needs to be awaited, and also we have a resolved promise which contains a then statement inside of which we have a console log which states promise callback. So when I run this, I will not ask you to think about this because we still did not cover how promises work and how Microtask queue works, but basically, as I mentioned, Microtask queue has higher priority than the event queue. So when I run this, promise callback should be, as is the case, above timeout callback, because Microtask queue has higher priority in JavaScript than event queue, and promises use this Microtask queue instead of event queue. And one final thing I would like to mention about event queues is the fact that all the events in our DOM are using event queue as well. So when, for example, a user clicks a button on our website, it also gets put into event queue, and then it waits for event loop to pick it up from there and push it to call stack in order to get handled and executed. So have in mind that all the events from our DOM are being pushed to event queue as well. Isn't it amazing how event queue and call stack make everything in JavaScript work so seamlessly? By understanding these two concepts, you are going to be able to be an amazing JavaScript developer, because you will understand how the engine itself, how the core of the language functions under the hood, and that will put you to a way better start than most people. I hope you found this video very useful and educational, and if you did, I would like to kindly ask you to subscribe to the channel and turn on the notifications, because in the next video we will continue going strong with core concepts, how the JavaScript engine works. So in the next video we will be talking about event loop of JavaScript. And there is nothing else I would like to say except to thank you for watching and wish you an amazing day. And as usual, happy coding!